Hi, I'm Minesh, and today I will introduce beer. Third-party DRAM consumers often ask the question, what are a DRAM chip's reliability characteristics? And this includes things like aggregate failure rates, minimum viable operating timings, and many other reliability-related questions. The way to answer these questions is with extensive DRAM testing and error characterization. So given a DRAM chip, we study the observed bit flips when errors occur. However, modern DRAM chips include on-die ECC, which are unknown and proprietary and provide no feedback to the CPU upon error correction. Therefore, on-die ECC obfuscates the errors we wish to study. This means that on-die ECC complicates third-party DRAM testing. And to overcome these challenges, our goal in this work is to determine exactly how on-die ECC obfuscates errors. In other words, its parity check matrix. In the context of a DRAM chip, we want to know exactly what happens within the ECC logic. To this end, we introduce BEER, a new three-step testing methodology that first induces uncorrectable errors in a DRAM chip, then aggregates unique error patterns observed, and finally solves for the parity check matrix given the unique patterns. BEER requires no special hardware or knowledge, and we release our implementation as open source on GitHub. We evaluate BEER in two ways. First, an experimental demonstration using real LPDDR4 DRAM, and second, in simulation to show BEER's correctness and practicality for various representative on-die ECC codes. Our experiments show that different manufacturers appear to use different parity check matrices, and chips with the same model appear to use identical matrices. Our simulations show that BEER works well for all simulated test cases and is practical in terms of both runtime and memory usage. To learn more about BEER and its use cases, please attend my talk at Micro 2020.